Okay, this video is on Math 120, and this is covering section 4.5 and 4.6. In 4.5, we are talking about at least one. And we're also talking about conditional probability. Now, at least one is a term that we use a good bit in math, and it basically means one or more. At least one. That means that the lowest number that you have is 1. So if the lowest number is 1, if you have a number line, and that number line goes from 0 to 5, 2, 3, 4, 5, and if I tell you at least one means that of all the numbers that you pick, the least number that you can pick is 1. At least one. Well, at least one means that we are talking about all the numbers above 1. So at least one also means 1 or more. And this is used a good bit in probability, and the complement of at least 1 is used in probability, because the complement of at least 1 is none. So the complement of at least 1 is the probability of none. Because if you take away the at least one, you're left with just one thing, which is the probability of none. So let's take a look at an example. It says in a certain country, the probability of a baby being born a boy, being born a boy is 0.509. So like 51% or 0.51 probability. Among the next 6 randomly selected births in the country, among the next 6 randomly selected births, what is the probability that at least one of them is a girl? What is the probability of at least one girl? Okay, at least one girl. What is the probability of at least one girl? So it seemed like to me that if you're talking about at least one girl, well, the probability of a child being born is 1/2 probability it's going to be a boy, and 1/2 probability that it's going to be a girl. So at least we know this much, and that's an assumption that's made, but in this case they are saying that the probability of being a boy is 0.509, so it's a little bit more than the theoretical probability of a boy. So we need to think about if at least one girl is the same thing as saying 1 or more girls. Okay, so let's think about that. At least one girl means 1 or more girls. So the only thing that complements one or more girls is all boys. Think about that. The complement of at least one girl or one or more girls is all boys. So if we can find the complement, then we'll have the answer to the question, because it's asking at selected bursts, what is the probability of at least one girl? Well, if we find the probability of all boys, then the complement of all boys would be at least one girl. Now you got to think about what this means, one or more girls. The only scenario where you don't have one or more girls is all boys. So you're basically talking about 6 boys. Boy, 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 boy. There's 6 boys because you have 6 random births. What's the probability of all of them being boys? Well, that's 0.509 times 0.509 times 0.509, or you could say 0.509 raised to the 6th power. Now, when you take 0.509 and raise it to the 6th power, you come up with 0.017. You've got a 0.017 probability that all 6 births are going to produce boys. Okay, now that's the complement. If 0.017 probability is all boys, then 1 minus 0.017 would equal at least one girl, because that's the only other scenario. If you have all boys and you know the probability of all boys, then anything else would be one or more girls. So 1 minus 0.017 comes out to be 0.983. And that is the probability of having at least one girl in 6 births. So here we use the probability of all boys and the complement of that to find the answer. Okay, and that's how you do an at least problem. Remember, at least 1 means 1 or more. At least 2 would mean 2 or more. At least 3 would be 3 or more. So the complement of at least 1 would be none. The complement to at least 2 would be the probability of none plus 1, or 1. And the probability to at least 3 would be the probability of none plus the probability of 1 plus the probability of 2, and so on. So that's how you do at least 1. Now, what is a conditional? What is conditional? Well, conditional, sometimes, most of the time, it's going to be given a table. So the data represents, let me just draw the table. And we have individual had the disease, and tested positive and negative for the disease. So we got 130 and 26 and 29 and 115. And this is yes, had the disease, no, did not have the disease. Alright, so that's the data you're given, and it says the data represents the results from a test on a certain disease. assume one individual from the group is randomly selected. So each one of these persons, they put their name on a piece of paper and put them in a hat. And they want to know, find the probability of getting someone who tests positive, probability of someone who tests positive, given that he or she has the disease. Okay, this is kind of like your addition and multiplicative rule, except you don't have a or and. It's given that. And once you see that given that, you know you're dealing with conditional probability. And what you do first is you find who has the disease, how many people have the disease, and that would be 130 plus 29. 130 plus 29. So first, find the probability of people who have the disease, and that would be 130 plus 29, and then let's see, that'd be 130. That's have the disease, and then find the probability of the total of, I think it's going to be 159. Let's see, wait a minute, hold on. No, you add the 2. Let's see, that would be the, I'm trying to remember, positive, tested positive. Yeah, that'd be 130. Okay, I'm glad I got a little mixed up. All right, so has the disease would be, that's your denominator, because this is going to be your denominator right here. So 159 is your denominator, and this is the probability of testing positive given that you have the disease. And how many people tested positive? 130. And that is your conditional probability. It comes out to be 0.818 probability. And that is basically the probability that a randomly selected individual who has the disease will test positive is 82%, or 0.82 probability. And that's called conditional. It's kind of a jump off or a spin off of the multiplicative law and the addition law, but you can't use it with that because we're not dealing with or and. We're not dealing with those. Or is addition and is multiplicative. We don't have an and. We have given that. And when you see the given that, that means conditional probability. And that is 4.5. Now, 4.6 is counting. Now, of course, we know, everybody in here knows how to count. But 4.6 is dealing with counting in a way that not many people count. Dealing with a lot of factorials and a lot of exponents. When you're dealing with combinations and permutations, you're going to be dealing with two things. You're going to be dealing with exponents, and you're going to be dealing with factorials. Okay, exponents is, 4 to the second power is equal to 16. All right, there's your exponent. And a factorial is 3 factorial is equal to 3 times 2 times 1, which is equal to 6. So there's an example of the two things that we're going to be using in 4.6. Now, if you look in your book, I don't know what page it's on, but I can look right quick. Where's my book? There, that's not it. That's not it. Let me go back and find the book for 4.6. Because there's one page that has all the information for you, and that page is trying to pull the computer up. 4.6, page 176. Page 176 has a good rundown of what we use in 4.6, and basically you're talking about the fundamental counting rule, which means that you might use an exponent, that you might multiply or use the exponent. Then you use the factorial rule, then you use the permutation rule and the combination rule. So you got several rules here. They're all on page 176. I'll go ahead and do a couple of examples, and you'll see that it's not very difficult. Let's go with a thief steals a debit card or an ATM card and must randomly guess the 5-digit PIN code from a 10-key keypad. Repetition of digits are allowed. What is the probability that the crook or the thief will guess on the first try? Okay, so let's write this down. Steals ATM card / debit card, and the card has a 5-digit PIN from a 10-key keypad. And that's just a basic keypad that goes from 1 to 0. So we're going to use the fundamental counting rule, which means that you're going to multiply, let's say there's 10 digits in each slot, so that means 10 to the 5th power, because you got 5 digits. So you got 1, 2, 3, 4, 5. You got 5 digits, and each one of these comes from a 10-digit keypad. So this one you have a choice of 10, 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 and this one you have a choice of 10. Now the reason you have a choice of 10 on each is because the directions say repetition of digits are allowed. If the digits are not allowed to be repeated, then you would have more of a without replacement, or without replacement. So this would be 10, 9, 8, 7, 6. So, you know, that's very important that you remember that in the directions, that this says that you can repeat. So that's kind of like with replacement. So our basic calculation is 10. Fundamental counting rule says 10 times 10 times 10 times 10 times 10. But we use our exponent and say 10 to the 5th, which comes out to be 100,000. Now, what is his probability of getting the first try? Well, that would be 1 out of 100,000. So I wouldn't put money on it, because that's a very low probability that he will actually get it on the first try. And this is a fundamental counting rule using an exponent instead of just multiplying 10 times 10 times 10 times 10. The second thing that we'll talk about is combination. A combination has no order. Remember that. That's the biggest thing that you have to remember about a combination. It has no order, meaning that you can put it in any order, like the different committee members of a committee. They don't have officers, then you can put them in any order. Alphabetical versus male and female. You can put them in any order you want to. I always like to think of eggs. You may have 15 eggs, but you can put them in any order because there's no designation of what kind of order there is, because they're all eggs, they all look the same. So you can put them in different arrangements, but there's no order. All right, a country music fan decides to make a customized CD with 20 of her favorite songs out of her 30 most loved songs. So in other words, she's going to make a CD of 20 songs out of the 30 of her favorite songs. So evidently the CD will only hold 20 songs. And she's got to pick how many, 20 out of the 30 songs. So we will have to do this as a combination, because the question says how many different combinations of 20 can you have out of the 30. Now there is a formula for this. NCR is equal to, I think it's n factorial over n minus r factorial times r factorial. Now this is the longhand way of finding this, how many different combinations of 20 songs out of the 30 can she have. Remember that n is always your biggest number. N is always the largest. So n here would be 30. Okay, remember that. N is always the largest. So if you went by hand and did it, it would be 30 factorial over 30 minus 20 factorial times 20 factorial. And then you would punch that in on a calculator and you would get the answer. There's also, on some of your TI-83s, there's also under math probability, I think math probability, I think you can look for this button. It'll be NCR. And you need to use that key instead of having to punch in all of this, and it'll save you a whole lot of time. You would type in 30 and then you type in, I think, math probability and then NCR and then 20, and then it would give you the same thing that this will give you, and that number is going to be a big number, 30,045,015, and that's how many different combinations of 20 she can have out of the 30 songs. So that's a pretty big number. Okay, so that's a combination. Well, what's a permutation? Permutation. A permutation is one that has order. And I like to tell students officers. Permutation basically order. And I like to tell students, if they see a problem with officers, there's a board and the board has to have officers. How many different combinations if these 30 people are picked to be on a 4-member board, and they have 4 officers or whatever the case may be. Anything having to do with order, you're going to use the permutation. It's similar to the combination formula. A permutation, NPR, is equal to n factorial. Well, I thought I had it, but evidently I don't. N factorial, I thought I had the problem going with a, I don't. N factorial over n minus r factorial. N factorial over n minus r factorial. So, n factorial over n minus r factorial. Now, in this case, you are going to have, let's see, a bigger number on the bottom, no, smaller number on the bottom, because you don't have to multiply by the r factorial. And in this case, if we were talking about there's 25 people to pick from. Let's say there's 25 people in a business, 25 executives, we'll say executives in a business, and they want to form a board of trustees. Okay, and the board, they will have to have 4 officers, and the 4 officers are president or chairman, and then the vice president, and then the secretary, and then the treasurer, whatever the case may be. And they want to know, out of the 25 executives, how many different combinations of this can they get. So that would be 25 P 4. Now, again, you could plug it in, and that would be 25 factorial over 25 minus 4 is 21 factorial, and that would be your answer. Or you could type it in, math, 25, math, probability, and then N, P, R, and 4, and that would give you, let me go ahead and do that on a calculator. I think I got one on here somewhere. Yeah, there it is. That would be 25 math, probability, NPR of 4, and that comes out to be 303,600. So that's how many different boards you can make up of 25 executives, and that gives you a good indication, you know, of how versatile it is to have 25 executives in a business, and you want to have 4 officers. How many different permutations of those executives, 4 executives on the board? How many different boards do you have? Possibilities, and that's over 300,000. And that's how you use permutation. You can also use the Excel spreadsheet by using the Combin, C-I-N-B-I-N, and Permute, P-E-R-M-U-T. And the way you would use that is you would type in combine equals combin, and then parentheses 25 comma 4 close parentheses, and then it would give you, in the cell, it would give you the answer. And if you wanted to find a permutation using the same thing, it would be 25 comma 4 close parentheses, and then that would give you an answer in the cell. So if you want to use the Excel spreadsheet, you can use Excel with the combination and permutation, as well as your TI, as well as doing it by hand. So I hope that helps you with 4.6, 4.5, and 4.6. I do break up the test on this unit, so we will be posting a test on Chapter 4, and then we'll move on with Chapter 5. Hope that helps.